guess before we get started with this, let me talk about your exam a little bit, which is tomorrow. Okay, your semester exam is tomorrow. It is 42 questions. It will be online. Okay, we're going to do it on Edge Elastic. The tech guys did come up with a way for us to use the secure browser for it, so that's not going to be an issue. We will have access to Desmos, and we will probably take a little bit of time on Wednesday to finish it up as well. It's taking people just a little bit longer than the hour. Okay, so don't worry about time. Okay, if you don't finish it tomorrow, we can spill it over into Wednesday. Okay, but as you're preparing for it, look through that list of topics that I gave you. Okay, if you lost it or you need another one, I've got plenty of extra copies over here in the tray. Okay, but do make sure that you look over some things to prepare for the tests tomorrow. All right. So today we're going to take a look at the triangle inequality theorem. Take out the earbuds, please. The triangle inequality theorem. Okay? The triangle inequality theorem just says that the sum of the lengths of any two sides has to be bigger than the third side. So what that means, if I take three side lengths of a triangle, okay, the two smaller ones have to add up to be bigger than the third one. The reasoning, okay, if we take a look at what it says up top here, if we take three straws or three things of length 8, 5, and 1. Right? So if I draw something of length 8 here, and then I draw something of length 5, I don't know, something like that, and then something of length 1, those aren't going to connect, right? That's not going to make a triangle. These two sides would have to add up to be bigger than the third side for them to connect, for them to actually make a triangle. Okay, so that's all this is saying. Right? The two smaller sides have to add up to be bigger than the third side. Okay, it can't even be equal. It has to be bigger than. Right? If these two added up, let's say this one was 5 and this one was 3. Okay, if we think about it, right, those would, if I put those on here and try to connect them, they would be the exact same length as the bottom here. I couldn't raise them up any and have them connected still. So these two sides have to add up to be bigger than the third side. Right? So we're going to go ahead and jump down to the exercise here. We're going to skip the example and come back to that in a second. Okay, but these first few exercises just say, here's three side lengths. Is it possible to form a triangle with these? Well, what we want to do is find the two smallest ones, add them together, and see if that sum is bigger than the third side. So for number 1, the two smallest ones are 3 and 4. Is 3 plus 4 bigger than 6? Yes. Right. So this is essentially what we're doing. Right. We want to test out, is 3 plus 4 greater than 6? Yes, it is. So 3, 4, and 6 could be the sides of a triangle. Okay. How about let's do number 3. How about 8, 8, and 8? Yes. Is 8 plus 8 bigger than 8? Yes. Right? So this one would also work. 8 plus 8 is 16. That is bigger than 8. Okay, so let's take a minute here and see what you guys can do with the other 4 problems. Okay, so all we're testing is to see if the two smaller ones add up to be bigger than the third one. If that's true, they can make a triangle. If it's not true, it doesn't make a triangle.
So, can I come up the kid? Come on, I'm a bedroom. See something last night. I'm in the bedroom. You gotta let her outside.
All right, did we get these answers? Yes, no, yes, yes, no, yes.
Yes, no, yes.
Yeah.
Yes.
All right. Any questions on this first idea?
No. Yes, no, yes, yes, no. No, yes, yes, no.
All right, so the second idea then, okay, is if we are given two sides of a triangle, we want to find the possible ranges for the third side. Okay, so we want to find the smallest it could possibly be and the largest it could possibly be. Okay, so if we're given, for this example up here, we're given side lengths of 5 and 8. We want to find the smallest that third one could possibly be and the biggest it could possibly be. So we said, if we've got sides of 8 and 5, right? So we have something like this, right? We want to find the smallest that this third side could be. Okay, the smallest would be, something like this, with a real small triangle like this, real big angle up here. All we're going to do to find the smallest that could possibly be is subtract these two numbers. Okay? So this side, we're going to say, has to be bigger than 3. Okay? 8 minus 5 is 3. It could be 3.1, right? Or 3.04. It just has to be bigger than 3. Okay? So 3 is the smallest that this side could be. If we want to think about the largest the third side could be, we want to think about, well, here's my 5 and 8 then. This longest side would just be, it would have to be less than these two sides added together. Okay? So the largest that this side could possibly be would be 8 plus 5, which is 13. Okay? Now the way that we're going to write this, we're going to write this as one inequality. So to write this as one inequality, we're going to say x has to be bigger or greater than 3, but x has to be less than 13. Okay, so this is how we write an inequality like that. So x is greater than 3, but x is less than 13. So we put it in the middle like this. Right. And to get those numbers, all we did was subtract the two side lengths to get the smallest one, and add the two side lengths to get the biggest one. Right? So notice, okay, we're saying x has to be bigger than 3. X can't equal 3. It has to be bigger than 3. And again, x can't equal 13. It has to be less than 13 for that third side. Questions on that idea? Okay, so down here, 7 through 10, we're just practicing that idea, finding the smallest and the largest the third side could possibly be. Okay, so let's take a minute here and see what you guys can do with 7 through 10.
Wake up.
So could it be 6?
So we just like adding these together, or I'm so lost.
So to get the Alright, these should be our answers for 7 through 10. Any questions on these?
It's pretty easy once you get a hold of it.